These gravels that we're seeing here are one, the rounded shape, but also the size. These are too large to be transported by wind. The consensus of the science team is that these are water-transported gravels in a vigorous stream.
When we looked at the layer with our high-resolution Mars-cam camera, we found that it was comprised of sand grains and small pebbles that had become cemented to form a hard layer. Here, you can see a pebble that is 3 centimeters in diameter, so smaller than a ping-pong ball. This suggests that this layer is an ancient gravel deposit. The surprising thing is that when we looked at the pebbles closely, we discovered that many of them were quite well-rounded. This is very different to the many angular clasts that usually litter the Martian surface. On Earth, rounded pebbles are a common telltale sign of rocks that have been transported by water, for example in a river or a stream. As water flows over a riverbed, if the flow strength is great enough, the pebbles are lifted up into the flow or rolled along the riverbed, and they become pounded, battered against each other, and this causes them to become rounded through time. So what we think we might be seeing here on Mars is an ancient riverbed with the pebble beds representing old stream deposits. The size of the pebbles tells us that these rocks could not have been transported by the wind.
Share with you today that we now have full confidence that there is methane occasionally present in the atmosphere of Mars, and that there are organics preserved in ancient rocks on Mars in certain places. This is important. Methane in the atmosphere and organics in ancient rocks are important because they are chemically reduced molecules. On terrestrial planets, they compete for destruction with other kinds of molecules that are more oxidizing. And their preservation and occurrence is a certain matter of luck, for which science must provide a search paradigm in order to better understand how these materials are produced and where they go. But most importantly, they can both be consistent with the former presence of life, or the existing presence of life.
This was an ancient environment with the right elements, minerals indicating a near neutral environment, and slightly salty liquid water. All the prerequisites to support life, a habitable environment.
I think we have found a habitable environment that is so benign and supportive of life that probably if this water was around and you had been on the planet, you would have been able to drink it.
So, although at this point in the mission we can't conclude that there was definitively life on Mars, the SAM discoveries have really shown us that all of the basic ingredients for life were there, including complex organic compounds, the building blocks of life. Now, with the detection of organics in Gale Crater, the probability that Gale Crater Lake could have supported life goes up.
Mars is very Earth-like, or at least used to be very Earth-like. It is a planet, sister planet to Earth. It is the most likely planet in our solar system that had life at one time, may have life now, and we feel definitely can sustain life. So that's the reason we chose it. It's definitely one about survival of the species, if you will. You know, the more we can expand humanity across the solar system, the more we're going to understand.